Unit 4, Quadrilaterals and Polygons, Lesson 5, Trapezoids and Kites. In this lesson, you will identify properties of trapezoids and kites, as well as use these properties to solve problems. Okay, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. Here, RS is parallel to UT. And the other sides are not going to be parallel. So this is not a parallelogram. The mid-segment or median of a trapezoid is the segment that connects the midpoint of the two legs of the trapezoid. So here RS and UT are both called a base. So this is one base and this is the other base. The two parallel sides are bases. And then the other two sides are legs. So if we have the midpoint here and here of those two legs, that is our median or mid-segment of the trapezoid. Its measure is equal to 1/2 the sum of the lengths of the bases. So if I add up base 1 and base 2, divide by 2, I get the length of the mid-segment. An isosceles trapezoid is a trapezoid with two congruent legs. So you see my parallel sides, and my two legs are marked congruent with my little tick marks. In an isosceles trapezoid, both pairs of base angles are congruent and the diagonals are congruent. So my base angles are here and here, so those are going to be the same, and here and here. And since the diagonals are congruent, I can say GJ is congruent to HK. Okay. Example 1. The vertices of A, B, C, D are A, -3, -1, B, -1, 3, C, 2, 3, and D, 4, -1. Show that ABCD is a trapezoid and determine whether it is an isosceles trapezoid. Well, the definition of trapezoid is that there is exactly one pair of parallel sides. So I'm going to look at the slope of opposite sides. Remember, our slope formula is m equals y2 minus y1 over x2 minus x1. Let's find the slope of BC first. So x1, y1, x2, y2. I'm going to have 3 minus 3 over 2 minus -1, or plus 1, which gives me 0 over 3, which is 0. And let's see if my segment AD has the same slope. So AD, we're going to have -1 minus -1, so plus 1, over 4 minus -3, so plus 3. We get 0 over 7, which is 0. Since both of these have the same slope, they are parallel. So I know BC is parallel to AD. Now we want to check the slopes of AB and DC and make sure that these segments are not parallel. So AB, we have y2 is 3 minus y1 is -1, so plus 1, over -1 minus -3, so plus 3. Gives me 4 over 2, which is 2. So I'm looking for a slope of 2 here. CD. we have 3 minus negative 1, so that's a plus 1, over 2 minus 4. This gives me 4 over negative 2, which is a negative 2. Okay, now these numbers are different. They are not the same. So A, B, and C, D are not parallel. So I can say, since A, B, C, D has exactly one pair of parallel sides, and I'm going to note that it's BC, which is parallel to AD. It is a trapezoid, but we want to find out if it's isosceles. So one of my properties of isosceles trapezoids is that the base angles and diagonals are congruent. So I'm going to look and see if my diagonals are the same length. That's something I can do with the distance formula. So distance formula, should probably have this one memorized by now. We have the square root of x2 minus x1 squared plus y2 minus y1 squared. And we want to find first the length of BD, that diagonal. I can draw it on here even. Okay, so y2 is 3, or let's look at x2, sorry. x2 is negative 1 and x1 is 4. So for BD, we said negative 1 minus 4, and it's y2. 3 and y1 is negative 1. So 3 minus negative 1 is 3 plus 1. Okay. So we get negative 5 squared plus 4 squared under our radical. Which is 25 plus 16. And that is the square root of 41. Okay, so if AC is also the square root of 41, we have an isosceles trapezoid. Let's see what happens. Okay, so x2 is 2, x1 is negative 3. What are we looking at, AC? Yes. So 2 minus negative 3 is 2 plus 3. And y2 is 3, y1 is negative 1. So 3 plus 1. Okay. Which gives me 5 squared and 4 squared. Which is 25 and 16, which is the square root of 41. Okay, excellent. So I'm going to bring my first part of my conclusion down and extend it with the information I just found. So the diagonals are the same, which means that this is an isosceles trapezoid. So I'm going to say, since the diagonals are congruent, ABCD is an isosceles trapezoid. Okay, and that's it for this example. Okay. Let's look at kites. So a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Opposite sides are not congruent or parallel. So consecutive congruent means that the sides that are next to each other are congruent. So here, MR and RP next to each other congruent. But since those are congruent, there's only two pairs, these are not congruent. So we have pair 1 and pair 2. And you can see a kite looks like a kite. The diagonals of a kite are perpendicular, so they meet at right angles. And here, exactly one pair of opposite angles is congruent. In this case, M is congruent to P. R and N are different measures. Okay, example 2. If WXYZ is a kite, find the measure of angle Z. So I can see here that W and Y are different measures. And since exactly one pair of opposite angles are congruent, X and Z are congruent to each other. I also know that there are 360 degrees in a quadrilateral. So I'm going to call this X and this X. And I'm going to say 360 equals 80 plus X plus 60 plus X. So I'm adding up the four angles and setting them equal to the number of degrees in a quadrilateral. Now I'm going to combine like terms. So I have some numbers. 80 plus 60 is 140. I also have variables. So this is 1x and 1x gives me 2x. The 360 doesn't change. Now I want to move this 140 to the other side of my equation, so I'm going to subtract 140. And I get 220 equals 2x, but I just want 1x. So let me divide by 2. And I get 110 equals x. So I wanted to find the measure of angle Z. I'm going to say the measure of angle Z equals 110 degrees. Example 3. If ABCD is a kite, find BC. Well, I've already been given the lengths of different parts of the diagonals here, but I want to find this portion that I'll highlight for you, BC. And if you look, we have a triangle right here that could help us. We know that the diagonals of a kite are perpendicular to each other, so I have a right angle at P. Okay, so angle BPC is a right angle. And when I have a right triangle, I can use the Pythagorean theorem to solve for a missing side. Remember, that's a squared plus b squared equals c squared. So a is 5, b is 12, and side BC is c. Let's simplify. 5 squared is 25. 12 squared is 144. When I add those together, I get 169 equals c squared. Now all I have to do to get c by itself is take the square root of both sides. And I get c is 13. So in other words, BC is 13, the length I was looking for. So that's pretty nice. And that is it for lesson 5 on kites and trapezoids.